Statistical Rethinking, second edition, chapter 13, in the hard questions here, and we're on question 13H2. Okay, so we are going back to the Trolley data set, and there we fit a model. In fact, we fit this model right here, where we are trying to model participants' responses to a bunch of trolley problems. And so hopefully you're familiar with what trolley problems are. Basically, they're little thought experiments where you're supposed to test your moral intuitions about a particular set of events. Usually it's, the most basic one is, there's somebody at the top of a bridge and you're on this bridge with them and you see a train or a trolley moving down the tracks beneath you and it's going to strike 5 people. Do you push the one person over, that will stop the trolley and save the 5 people? And there's different iterations of this, and the different iterations with the variables there are encoded in our data set by things like action, intention, contact, etc. Okay. What we are meant to do here is to model it, but now for each of the participants, they get their own random intercept. Okay. So this is the model that is in chapter 12, and we're just adding a random intercept here, and that's it. Okay. If you're going to run this in the Colab sheet, I suggest you don't. I suggest you run this on your local machine. This took a very, very long time to run on Colab. I'm not really sure why, but okay. Let's go through this. So the only difference, the only change that we're making is to add this random intercept. Okay. So again, this is the model that's presented in the chapter, and we're just adding this guy right here, which again is a random intercept for each individual in the data set. Okay. And so now, having done that, we are supposed to compare the two models, both using WAIC and posterior predictions. Okay. So what is the impact of variation in this data? Okay. So let's look at the WAIC score first, right here. So we can just use the compare function and our two models, and it defaults to WAIC. Okay. And we see that the random intercept model, this one right here, is superior to the non-random intercept model. And this is kind of interesting because look at the discrepancy in the number of parameters here, 354.8 versus 11, basically. But still, the costs that we're paying for these random intercepts are doing more than enough to offset their expense. Now, what about these posterior predictions? That's worded just a little bit weird, I guess, because it's not really specifying what we mean by posterior prediction. So we could do something like the post check command, but I'm not doing that because everything else took so long to run, and I imagined that would take a very long time to run, and I just didn't want to wait. We could plot posterior predictive distributions, but I don't really know. I'm not really sure what we're supposed to do here. So instead, I'm just plotting the posterior coefficients, the main coefficients here. Okay, so we have BA, BC, BIA, from the model, and the two different models. Okay, and so you see that you can see you can see the difference between the two. I guess that's all that there is to say there. I suppose you also, I think it's probably all of them, where the coefficients are small. How do I want to say this? Smaller is a little bit misleading. They're more negative, right? They're we're all, so if you look at the x-axis here, everything is negative, and so we're on the logit scale. If I can get up here, so we're on the logit scale here, and so more negative means that there is less of an influence of each of these particular parameters, or however you want to say that. And so I guess it's a little bit not surprising that once we account for the variation among individuals, that the rest of the parameters have a more negative estimate, right? Because they're less important to determining the outcome the predicted outcome. I guess having said that, we'll call that good.